Okay, so today we're going to continue with our study of zeros of polynomials, and we're going to start with the factor theorem. The factor theorem says that x minus k is a factor if and only if f of k is 0. So what that says is if you take whatever was here, if we had x minus 3, then k would equal 3. So if we find out what f of 3 is, we plug that k or that x value in. If it equals 0, then x minus 3 was a factor. So let me show you with an example. So the first problem says, determine if x minus 1 is a factor of the polynomial. So remember, we take the factor x minus 1 and we set it equal to 0, add the 1 over, so now we know x equals 1. That's what's going to go in our house, the 1. And then we need to check this polynomial and make sure it's in descending order. And we have to add in the missing terms if there are any. So my powers are 4. Oh, I'm missing that 3. There's that missing term right there, the 0x to the third, because it goes 4, 2, 1, none. So let's rewrite this polynomial. F of x equals 2x to the fourth plus 0x cubed plus 3x squared minus 5x plus 7. Now we can set up our synthetic division. Let me erase this one. It's not wrong. I'm just going to rewrite it. So 1 goes in my house. 2, the 0 for that missing term right here. Positive 3, positive 2, negative 5, and a 7. So we're going to drop the 2 down. Remember, below we multiply and above we add. So we drop the 2 down. 1 times 2 is 2. 0 plus 2 is 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. 1 times 0 is 0. 7. So that means f of 1, the thing we put in our house right here, equals 7. Since it doesn't equal 0, like it said it had to do right up here in our theorem, then no, x minus 1 is not a factor. Let's try another one. So we'll check that it's in order first right here. 5, 4, 3, 2, 1, none. So it's in order and no missing terms. We know we're going to put 1 in that house because we're using the same statement up here. Then we put our numbers, 3, negative 2, 1, negative 8 are coefficients, 5, and then 1. Above the line we add, below the line we multiply, drop the 3 down to start. 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 8 plus 2 is negative 6. 1 times negative 6 is negative 6. 5 plus negative 6 is negative 1. 1 times negative 1 is negative 1. Remainder of 0. So f of 1 equals 0. That means that yes, x minus 1 is a factor. So on the next page, we're going to use the same thought process and be able to find all the factors. So it says to factor the polynomial you're given, 6x cubed plus 19x squared plus 2x minus 3, into linear factors, given that negative 3 is a 0. So if negative 3 is a 0, we'll put negative 3 in the house. And before word numbers, check 3, 2, 1, none. So no missing terms. So 6, 19, 2, negative 3. Drop the 6 down. Negative 3 times 6 is negative 18. Positive 19 minus 18 is 1. Negative 3 times 1 is negative 3. 2 plus negative 3 is negative 1. Negative 3 times negative 1 is a 3, remainder of 0. And that should happen because they told us that this is a 0, so we should have gotten a remainder of 0. I started with an x cubed, and I pulled out a single x. This is like saying x plus 3. That takes these numbers down to a power lower, or a square. So this is a 6x squared plus 1x minus 1. So now I'm going to take this, and since it's a quadratic, I either can factor it or use quadratic formula. So that is the goal when you're doing this, is to get down to a quadratic, because you know how to always deal with a quadratic. 6x squared plus x minus 1. I'm going to do that a times c, get a negative 6. I need 2 factors into negative 6 that add up to make a positive 1. So I'm going to do positive 3 and negative 2. I'm going to rewrite 6x squared plus 3x minus 2x minus 1. Just remember, if I combine these two combined like terms, I get back to this 1x that I had. So I never really changed anything. Gonna make groups. Here's my blue group. My blue group has 3x in common. I'm left with a 2x plus 1. And in my black group, they have a negative 1 in common. So I'm left with 2x plus 1. And then both of them have this 2x plus 1. So I pull out the 2x plus 1. And in the blue group, I'm left with my 3x. And then my black group minus 1. So it says to factor this thing into its linear factors. So that means that f of x equals the x plus 3 that we started with up top. And then I'm going to have 2x plus 1 from right here. And then the 3x minus 1. And there's my answer, factored into its linear factors. So the next thing we're going to look at is called the rational zero theorem. And it gives us a method to determine all the possible, not actual, but all the possible rational zeros. I just want to emphasize this word. It is just the possible ones, not actual. So what we're going to do is we're going to make a list of numbers. And we're going to make a list that's called the P over the Q's. P's are the factors of the constant term. And Q's are the factors of the leading coefficient. So, like always, they are the golden rules at this point. We need to make sure that this is in order. So 4, 3, 2, 1, 0. So this right here is the leading coefficient. So this is where my Q's are going to come from. This is the constant, the thing with no x's on it, and this is where my p's are going to come from. So to make a list of my possible rational zeros, first, p over q. I'm just going to list the factors. So p, the numbers that go into 2 are 2 and 1. So plus or minus 2, comma, plus or minus 1. The numbers that go into 6 are 6, 3, 2, and 1. So Q is going to be plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. And to make the actual list of these, what you're going to do is you're going to do P over Q. So you're going to do 2 over 6, 2 over 3, 2 over 2, 2 over 1. So 2 over 6 reduces to a third. So I get, plus or minus 1/3, comma. 2 over 3 is plus or minus 2/3, comma. 2 over 2 is plus or minus 1, comma. And then 2 divided by 1 is plus or minus 2. And then I have to do the same thing with the 1, I have to do 1 divided by 6, 1 divided by 3, 1 divided by 2, 1 divided by 1. So 1 divided by 6 makes plus or minus 1/6, comma, 1 over 3 is 1/3, but I already have 1/3 in my list. 1 over 2 is a half. And then 1 over 1, I already have 1 in my list. So these are the possible numbers in this list. It's 1, 2, 3, 4, 5, 6. It's 12 long because you have the positive version and the negative version. So this is all my possible rational zeros. So rational numbers, remember, are something that, like a terminating decimal or something that we can write as a terminating decimal. So 2/3 is 0.6 repeating forever, but because I can write it as 2/3, it becomes a rational number. So now what I'm going to do is I'm going to pick numbers and I'm going to do synthetic division until I find a remainder of 0, because that will mean it's a factor. And I'm hoping, personal opinion, I'm just hoping that 1 or 2 will do it, because I don't feel like doing it with fractions today. So let's start with positive 1. So I'll put 1 in my house. I'm going to grab those numbers up here, the coefficients, 6, 7, -12, -3, and 2. Now this is to not say that fractions won't work. They will work, but I am hoping that the whole numbers help me out today. So I'll drop down the 6. 1 times 6 is 6. 7 plus 6 is 13. 1 times 13 is 13. -12 plus 13 is 1. 1 times 1 is 1. -3 plus 1 is -2. I might have been the best guesser today. 1 times -2 is -2, remainder of 0. That means that 1 is going to be a 0, which means that x minus 1 is a factor. 1 is a 0, because I got a remainder of 0. X minus that 0, x minus 1, is a factor. So now it says I have to find all of the linear factors. What I'm going to do is I'm going to start using these new numbers. And I'm going to try to find another 0 that works. Now, it could be that 1 works again. It may not. So I'm going to try -1. So I'm just going to draw a new house and do -1. I'm going to use the new numbers. So I'm going to drop down that 6. -1 times 6 is -6. 13 plus -6 is 7. 1 times -7 is -7. 1 plus -7 is -6. -1 times -6 is 6. This is a remainder of 4, so this is no. So this one's no good. So let's try again. I'm going to put something in the house, and I'm going to use, again, these new numbers right here. 6, 13, 1, and -2, because you've already pulled a number out, so let's keep going in that pattern. So I've done 1 and -1. Let's try the 2s. Let's start with -2. We're already doing negatives, why not? So I dropped down the 6. -2 times 6 is -12. 13 plus -12 is 1. -2 times 1 is -2. 1 plus -2 is -1. -2 times -1 is 2. Hey, remainder is 0. So that means that -2 is a 0. X minus -2, so x plus 2 is a factor. Now we have a power of 4 right here. That means I have to find 4 factors, 4. So remember I said this earlier in the video. This is what you want to get to. This is a quadratic. I started at a 4th degree right here. I pulled out 1. So now this is a 3rd degree right here. I pull out another one. Now this is a quadratic. And if you ever forget, you can take these numbers and do it like this. -1 gets x to the 0th. 1 gets x to the 1st. And you just keep going up by 1, so this is x squared. Anything to the 0th power is just 1. So this really is 6x squared plus x minus 1. And we factored this a couple seconds ago, but let's factor again for good practice. So 6 times -1 is -6. If we get to quadratic, we can always factor a quadratic formula. -6 that adds up to +1 is a 3, and -2. So I have 6x squared plus 3x minus 2x minus 1. The first two have a 3x in common. 2x plus 1. These two have a negative 1 in common. 2x plus 1. They both have this 2x plus 1. And then you get 3x minus 1. So here are two more factors. So now that I've done all of this, it says factor this into its linear factors. So f of x is going to equal, the first one I pulled out was x minus 1. Then, hang on, it's not going to fit. So down here, the first one I pulled out was the x minus 1, then a x plus 2, and then these two right here. 2x plus 1, 3x minus 1. 1, 2, 3, 4. Remember, I was looking for a power of 4 earlier, so this is my answer. So the fundamental theorem of algebra says that every function defined by a polynomial of degree 1 has at least one complex zero. So it doesn't mean it has to be a real zero or an imaginary zero. It could have an I, could not have an I, but it has to have a zero. At some point in time, we have to account for that x being in the equation. So every x that you add is another zero that we have to account for. So the number of zeros, a function defined by a polynomial of degree n has at most n distinct zeros. So that's like saying if I said, I could say f of x equals x to the 5th minus 3x squared plus 1. This thing's degree is 5, so there's at most, So there's at most 5 distinct zeros. So what that means is there are definitely 5 zeros we have to count for, but they could be 5 distinctly different ones, or some of them might count more than once, but we have to account for all 5. We could write something like f of x equals x minus 1, x minus 3, x plus 2. The power here is 1, the power here is 1, the power here is 1. When it's multiplied out like this, its degree, you have to add them up or FOIL it out. So n here is 3, so at most 3 distinct zeros. So let's try. It says to find a polynomial of degree 3 with real coefficients that satisfies the given condition. So if these are zeros, I'm going to take them and I'm going to write, you're always going to write x minus whatever the zero was. So x minus 1 makes x plus 1, x minus 2, x minus 4. So this is not my polynomial, because I'm going to have f of x equals your leading coefficient a. And so that's where the second piece right here comes in. This is like saying x is 1 and y is 3. So y is 3 equals a, and all the x's become 1. 1 plus 1, 1 minus 2, 1 minus 3. This is 2 times negative 1 times, oops, I wrote the wrong number. This should be a 1 minus 4 minus 3, and then 3 equals a. So it's going to be 3 equals 2 times negative 1 is negative 2 times a. Negative 3 is going to be a negative 6a. Nope, sorry, positive 6a. Negative times a negative is positive. And then divide the 6 over. So 1/2 equals a. So now we can write our polynomial as f of x equals 1/2 x plus 1, x minus 2, x minus 4. We can also multiply this out. So I'm going to take the first two here and FOIL them. X squared minus 2x plus x minus 2. And then I'm going to multiply in that third one. I'm going to combine like terms first though. So in the red piece I get x squared. Negative 2 plus an x makes a negative x minus a 2. and then x minus 4, and then I can FOIL this. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative x times x is negative x squared. Negative x times negative 4 is plus 4x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is plus 8. We can combine like terms, so we get x cubed minus 5x squared plus 2x plus 8. And then we have that 1/2 out front. So we get 1/2 x cubed minus 5 halves x squared. A half times 2 is just 1, so plus x, and then plus 4. So I can write it like this. This would be called standard form of a polynomial. Or I could have written it like this right here. This is factored form. And this is definitely degree 3 because I have 1, 2, 3. Or down here, I have a degree of 3. Let's try one more. Okay, this one says that negative 2 has a multiplicity of 3. So first of all, remember it's x minus whatever the 0 is. So I get x minus negative 2. It makes an x plus 2. And the word multiplicity means what the power is on this factor. So my multiplicity is 3. So I have f of x equals a x plus 2 cubed. So then I use this last piece of knowledge where the negative 1 is my x and the y is my 4. So 4 equals a negative 1 plus 2 cubed. 4 equals negative 1 plus 2 is 1. 1 cubed is 1. So a equals 4. So I can write my polynomial in factored form. F of x equals a was 4, x plus 2 cubed. This is factored form. That's an acceptable answer. We can write it in standard form by multiplying out this x plus 2. So I have to do x plus 2 3 times. X plus 2, x plus 2, x plus 2. So if I do these two first, I get x squared plus 4x plus 4. And then I have to multiply that times another x plus 2. And you're going to get x cubed plus 2x squared plus 4x squared plus 8x plus 4x plus 8. Combine like terms. X to the third plus 6x squared plus 12x's plus 8. And then final step, that 4 out front. So in standard form, it would be 4x to the third plus 24x squared plus 48x plus 32.